Hi students, today we are going to discuss function. A function between two sets A and B is a special kind of relation between A and B. We have studied a relation in our earlier classes. There we observed a relation between two sets A and B is a association by means of some principle, some rule, okay, or some guideline, what you all can define by a relation, okay, is that where the elements in the set A is associated with elements in the set B. Now the point is that relation, if we make some restriction on it, it leads to a function. What is that restriction? A function between two sets A and B is a rule by which each and every element in the set A is associated to an element in the set B, specifically to a unique element in the set B. So there are two restrictions. One is that each and every element in the set A should be associated, which restriction was not there for relation. And the second restriction is that the association from the element in the set A should be unique association in the set B. Okay? Let us understand by means of some examples. Suppose I have two sets A and B. The set A contains, suppose, four elements: A1, A2, A3 and A4. And the set B, let's contain four elements: B1, B2, B3 and B4. Now let's define the association between the set A and B. Suppose A is related to B3, A2 is related to B1, A3 is related to B4 and A3 again related to B2. This is a relation we understood by means of our earlier classes, but this is not a function. Why you know? Because there exists an element, because of two reasons it is not a function. Two restrictions have been violated here. Number one, that element A4 doesn't have any association in the set B, whereas the definition of function tells us that each and every element in the set A. So that is getting violated. It is not each and every element. A4 is there, which is not associated to any element in the set B. And the another reason, suppose why it is not a function, but before that let us define, okay, A4 is related to B4. Then also it is not a function. The other rule is actually getting violated, other restriction is getting violated. What are the restriction? That each and every element in the set A should be associated to an unique element in the set B. So here we see that the element A3 in the set A is associated to different elements in the set B, B2 and B4. Alright? And that is the reason it is not a function, but it is a relation. So, to have this association qualified to a function, what are the things we need to do? We need to remove any of the association where A3 is associated. Now it is a function. Now it is a function. we can tell this one A4 is associated to B3, then also it is a function. There is no restriction that every element in the set B should have some association in the set A. That restriction is not there because the function is from the set A to B. And again, see, there are two different elements A1 and A4 associated to the same element B3. That is also not a violation of the restriction. Why? Because A1 is associated to B3, that is a unique association with respect to A1. A4 is also associated with B3, that is a unique association with respect to A4. Yeah. So that is the reason it is not it is not violating a restriction to qualify this association to be a function. So now let's come to the terminology. A function is defined like this: f colon a to b. With respect to this kind of association, f colon a to b, f is known as a function. Here I'd like to say one thing, is that the function and mapping, these two words are synonyms. Okay, sometimes you will find there is a mapping f from the set A to B means the same thing, there is a function from the set A to B. Okay, now this is known as the domain set with respect to the function f, and this set B is known as the codomain set. And f is the name of the function, right? So how we are representing it? Suppose there exists an element x belongs to the set A, for which we get an element y in the set B, such that x is related to y by means of the function f. If this is the case, we can represent it mathematically as equal to y equal to fx. I repeat, for an element x belongs to the set A, if we get an element y belongs to the set B such that x and y are related by means of the function f, then we can write y equal to fx. Okay. Example, you take y equal to sin x, you give different values of x, you will get different values of y. Right? So that means we can tell x and y are related by means of the function sin. Y equal to e power x, you give each value of x, you will get a different values of y. So that x and y are related by means of the function exponential. Correct? Now, the point is, the set A, the elements of the set A is associated to the element in the set B. Now, that set is known as a range set. Let me clear once more. Let's take this example. Here, the elements A1, A2, A3, A4 are related to the elements B1, B2, B3 in the set B. Right? Now, what we can see this is that, so here all the elements in the set A is actually confined to be associated in the set B by means of these elements. Now, this set is known as the range set of A with respect to the function f. So that means it is denoted by fa. Fa is the range set. Is the range set. Obviously, one conclusion we can make: fa is a subset of B, and more precisely we can say fa is an improper subset of B. Why? it may possible each and every element in the set A is associated to the set B, where all the elements of the B, all the elements in the set B has been covered. In that case, Fa will be equal to B. And if it is not the case, then Fa will be a subset of the B, set B. Right? This is a proper subset of the B, which is the case here. So there are two cases we can observe here. One thing, I can write it here, is that Fa could be a proper subset of the set B, or Fa could be equal to B. Now there are some mathematical terms. If these things are happening, then there are some mathematical terms to define. If Fa is a proper subset of B, we can tell this as into mapping or into function. Into function. And if this is the case, then we tell it as an onto function. So in case of onto function, what we see is that all the elements in the set B is actually has association in the set, all the elements in the set A. But into function, we can find there exists at least one element in the set B which is not associated with any element in the set A. Correct? So we have defined about the domain and codomain set, range set, into function, onto function. Now we are going to discuss about some very important classifications of functions. These are known as injective function, surjective function, followed by bijective function. Let us understand what is injective function first. Let me wipe it off. Let f a to b be a function okay and will be known as injective function if for x1 x2 belongs to the set A, x1 not equal to x2 implies f of x1 is not equal to f of x2. Okay, what is meant by that? Let's understand. Suppose by means of an example, let's understand by means of an example. Suppose this is a set A, this is a set B. So I have two different elements. Here is the element x1, here is the element x2, and x1 is related to what? Which element? Any element that is known as the fx1, and x2, where it is associated, it is known as fx2. Now this function f a to b will be known as an injective function if x1 and x2 are if x1 and x2 are different. That should imply that fx1 and fx2 has to be different, right? For example, let's take the function y equal to e power x. You take different values of x, you will get different values of y. Okay, it is not possible to find two different values of x, okay, and you are getting the same value of y by means of this exponential function y equal to e power x. So that's why it is known as a injective function. Let's take a counter example, y equal to sin x. So y equal to sin x. You remember what is the value of sin 0 is 0. So sin 0, you know the sine curve, and sin 180 degree, it is again 0. So I get two different values of x, one is 0, one is 180, but the sign of those two values are same. That means what? I get two different values, 0 here, 180 here, but I am getting the same value, right? So what is the expression here? So if here is the set A and here is the set B, I am giving two values, one is 0, one is 180, but the sign of this thing both leads to the value 0. Alright? That means this is the sine function. Okay? So this is not an injective. So this is not injective. Y equal to sin x is not injective. But y equal to e power x is injective. Because you take any two different values of x, you will get always different values of y. That is called injective. And sometimes that function injective is also known as 1 1. 1 1. And you understood why it is 1 1, because you take one element in the set A, the domain set A, you will get distinct element. You get a unique element in the set codomain set B, which is not associated with any other elements in the domain set A. That is 1 1. That is called injective. Next one will be known as injective surjective. Surjective. If it is an onto function. That means, if you remember, onto function, each element in the codomain set B has some association in the set A. Should have some association in the set A, right? It is so. If you remember in our just a few minutes back what we discussed, so here it will be FA should be equal to B. That means the range set of the domain set A should be equal to the codomain set. Then you can say this is a surjective function or surjective mapping. Or we can define here in this manner: if for any element y belongs to B, what is the B? B is the codomain set. There exists an element there exists an element x belongs to A. What is A? The domain set. Such that y equal to fx. Then it is known as surjective. Whatever I write it in English statement can be described by means of mathematical notation of a single statement, f equal to b. That means what? You take two sets A and B. Suppose here the elements are, there are 4 elements, A1, A2, A3, A4, and you are getting 3 elements, B1, B2, B3. Now, if the mapping or function is something like that, A1 is B2, A2 is B1, A3 is B2, A4 is B3. Then you can say this function is a surjective function, right? But interestingly, one thing you can observe here, though it is surjective, but this is not injective. Why? I get 2 distinct elements, A1 and A3. Both of their association, or sometimes it is also known as image. Image in the set B of these 2 elements, A1 and A3, are both B2. So though A1 and A3 are different, their image in the set B, association in the set B, by means of that function f is same. So this is not injective, but this is surjective. Alright. And the last one is called bijective. So before that, so surjective is also known as onto. Bijective is nothing but a function will be said to be a bijective function if it is both injective and surjective. That means if it is both 1, 1 and 1, 2. So that means if f is both injective and surjective. So it has to be both injective and surjective. Then you can say it is a bijective function. So in this region we have discussed about injective function. In this region we talked about surjective function, and here we talked about bijective function. Okay, so these are the examples, okay, where I spoke about surjective. Here is the example and counter example of injective. So what I will suggest you, please spend 2 minutes, okay, in this understanding injective, surjective, bijective. Then we will come to our next topic in this unit, function.